Welcome to Coding with Arduino for Young Innovators. So far in this series, we have been building Arduino projects, but without the Ettronics Hightech Arduino Kit. Today, we will start using the Ettronics Hightech Arduino Kit, and if you have not gotten yours, you can send us a DM or use the link in the description of this video to get yours. Please note that this video is for those who want to learn gradually, step by step, and really understand what we are doing. So if you are looking for a fast-paced video, this tutorial may not be for you. The first project we will build with the kit is a simple LED circuit, which we built in part 3 of the series. This time, however, we will build it with the component from the Ettronics Hightech Arduino Kit, so you can follow along with your own kit. After building the project, you will be given an assignment to modify the circuit and practice what you have learned on your own. But before we start building the project, I will have you watch the video where I explained what electricity is, what a circuit is, the difference between open circuit and closed circuit, how to identify a battery and explain its work, how a breadboard is arranged and connected, what jumper wires do, how to identify the legs of a light emitting diode, also known as LED, what a resistor does, and how a switch works. So let's get started. What exactly is electricity? Electricity is a form of energy that can move from one place to another. You cannot normally see electricity with your eyes, but you can see what it does. For example, when a bulb lights up, when a fan spins, when a television turns on, when you charge a phone, electricity is helping those things work. Imagine water flowing inside pipes. Water moves from one place to another inside pipes. Electricity behaves in a similar way, but instead of pipes, electricity moves through wires. Electricity has one important rule. It needs a complete path to flow. If there is a broken path, electricity does not flow. That complete path is called a closed circuit, and the broken path which does not allow electricity to flow is called an open circuit. This is a battery. This battery supplies electricity to our projects. A battery supplies energy to our projects to make them work. Without this energy, our projects will never come to life. You can think of it as food for electronics. Notice that it has two terminals or heads. Here we have the positive terminal, and here we have the negative terminal. Electricity leaves the positive terminal and returns through the negative terminal. This component is called a breadboard, and no, we don't eat bread on it. In electronics, a breadboard helps us build circuits easily. At first, it looks like many tiny holes, as you can see here, but hidden underneath are metal connections. Without a breadboard, we may need to twist the legs of our components when we connect them. But with the help of these metal connections of the breadboard, we can connect the legs of our components without damaging them. On this type of breadboard, all the holes from here to here are connected, and then we have a gap here, and all the holes from here to here are connected. The same thing is what we have on this line and this line. However, the holes on this line, that is this first line, are not connected to the holes on this second line. But the hose from here up to this point are connected, and here we have a gap. And then the hose on this line are connected up to this line. And what we have on this first line is also what we have on this second line. But there's no connection between this line, that is the first line, and the second line. Remember that we have a gap here separating these two lines from these two lines. For this side, the hoses are connected vertically. So we have connection from this line to this point, from this line to this point, from this line to this point. But we don't have connection from this line to this line, or from this line to this line. That is, the holes on this side are connected vertically. They are not connected horizontally. Now you can see that we have a demarcation here. So this demarcation separates what we have on this side from what we have on this side. And what we have on this side is exactly what we have on this side. So this is how a breadboard is arranged and connected. To demonstrate what I just said, let's make some connections. If I want to connect one leg of each of these two components, here I have two components. If I want to connect one leg of each of these two components together, instead of twisting them, I can fix the leg of one component in this hole, like this, and fix the leg of the other in this hole. So because we have continuity on this line, the two legs are now connected. I can do the same thing on this line, this line, this line, this line, up to this point. I can also do the same thing on these lines or on these lines. As long as you have continuity on any line, you can use it to connect the legs of your electronic components together without twisting the legs of the components. These are jumper wires. Jumper wires are like roads. They help electricity move from one component to another. Here we have three different types of jumper wires. The male-to-male jumper wire. This is the male-to-male jumper wire. You can see the pin. And then we have the male-to-female jumper wire, and then the female-to-female jumper wire. Let's say you want to connect one leg of each of these two components that are far from each other. You can use a male-to-male jumper wire to make the connection with ease by connecting one pin of the jumper wire here and the other pin of the jumper wire here. By doing this now, you have connected this leg of this component to this leg of this component. By connecting one pin of the jumper wire here and the other pin here, the legs of the two components are now connected together. This is a light emitting diode, which is abbreviated as LED. It is simply a device that turns on and glows light when electricity flows through it. An LED has two legs. The longer leg is called the positive leg, and the shorter leg is called the negative leg. As you can see, this is the longer leg and this is the shorter leg. So this is the positive leg and this is the negative leg. The LED comes in different colors. As you can see here, we have different colors of the LED. LEDs are special because they allow electricity to flow through them only in one direction. That is, from the positive leg to the negative leg, and not from the negative leg to the positive leg. We shall learn more about that when we start building our project. This is a resistor. Its work in a circuit is to slow down electricity flow. so that it will not damage other components in the circuit. Imagine a playground slide with children sliding too fast. A teacher might slow them down so nobody gets hurt. That is exactly what a resistor does in a circuit. Because a resistor resists electricity, we say that a resistor has resistance. Without a resistor, too much electricity can damage our LED, and that is what we don't want to happen with our projects. Resistors come in different values. The higher the resistance of a resistor, the more electricity it will resist in a circuit. When we tell the value of a resistor, we attach a unit to the value to make everyone understand that it is the resistance of a resistor that we are talking about. The same way we attach dollars or naira or pounds to money, so that everyone will know exactly the currency we are talking about. The unit of resistance is ohms, and it can be represented with a symbol called omega. This is a switch. A switch helps us to create open circuits or closed circuits. When a switch is closed, it means that it has closed all the openings in the circuit. Hence, electricity can now go around the circuit through the wires that will make our circuit turn on. But if the switch is open, it means it has created an opening somewhere in the circuit. Hence, electricity, which was supposed to pass through the wire, will no longer pass through. That way, our circuit turns off. Because we use a switch to turn on and turn off our circuits, we say things like switch on and switch off. Basically, what is inside a switch is wires. When a switch is turned on, the wires join together, and when the switch is turned off, the wires separate from each other, breaking the circuit so that electricity can no longer flow. Before we build the circuit, let's quickly look at how these components are represented in circuit diagrams. In electronics, we use symbols to represent components. This is a battery, and these are the symbols we can use to represent a battery. This is an LED or light emitting diode, and this is the symbol of a light emitting diode. This is a resistor, and these are symbols we can use to represent a resistor. This is a switch, and this is the symbol of a switch. This drawing is called a circuit diagram, also known as a circuit schematic. A circuit diagram shows how electronic components are connected using their symbols. Here, you can see the battery connected to the switch connected to the resistor connected to the LED. The LED connects back to the battery, forming a complete circuit. Right now, the circuit is open, as you can see here, because the switch is not closed. This switch here is not closed. Since the circuit is open, electricity cannot flow through the switch. For electricity to flow from the battery and around the circuit, the switch must be closed. Once the switch is closed, the circuit becomes a closed circuit and electricity can flow. Remember what we discussed about open circuits and closed circuits. Now that we have learned about some of the basic electronic components used to build electronics projects, let's look at the components included in our kit that we will be using to build the project. They are a breadboard power supply, a battery holder, 6 AA 1.5 volts batteries, one 220 ohms resistor, a switch, one LED or light emitting diode. You can use any color of your choice, and some male-to-male jumper wires. This is the breadboard. Now, if you look at this breadboard, you can see that we have a red line drawn here and a blue line drawn here. You can see that we have a positive sign on the red line and a negative sign on the blue line. This goes to show that we can use this red line to connect our positive power supply, and the red line can serve as the negative or the ground. And what we have on this side is also what we have on this side. This is the breadboard power supply module. This power supply module supplies power to our breadboard. You can see that it has pins that can fit into the breadboard. I can connect it this way. And you can see that it is fitted in properly. I can also connect it this way. And you can see that it is connected properly. Now what happens is that with this breadboard power supply module, we can supply power to our breadboard. This power supply module has a switch to turn it on and to turn it off. It has a power jack where we can connect power to it. It also has a USB port through which we can also connect power. It has a power indicator, a green LED power indicator. Here it has some header pins where we can connect jumper wires to take electricity to our projects. Here we have some header pins. Here we have 3.3 volts and here we have 5 volts. To select 5 volts, we have this switch which we plug here. This switch, this is a jumper switch, we plug it like this. When we do that, these pins will produce 5 volts. However, if the voltage we want to deliver to the breadboard is 3.3 volts, or the voltage we want to deliver to our project is 3.3 volts, we will remove this jumper switch and plug it here. That way, we have set this pin to produce a 3.3 volts power. The same thing is what we have here. This is the 5 volts and this is the 3.3 volts. So if I want to select 3.3 volts for this pin, I will move this jumper switch here and put it here. And if I want 5 volts, I will remove it from here and put it here. Now, if I want to take power from this board and connect to my circuit using a jumper wire, I can connect the jumper wire here. So if I want to connect 5 volts to my project, I can use a female jumper wire to take 5 volts from here. If I want 3.3 volts, I can connect it to these 2 male header pins and then connect to my project. These pins, these 4 male jumper pins are ground. So if you look back at these pins, you can see here that we have positive and negative. Positive and negative. And here also we have positive and negative. So when I connect this power supply module here, you can see that here we have negative, and here is where we have the blue line which tells us that this rail will give us negative voltage because we connected the pin to this rail. While this one comes to the red rail which gives us positive voltage. And if you look at this side, you can see that here we have the negative which is blue, and here we have the positive which is red. So when we connect this module on this breadboard, this rail will give us the positive voltage, that is the red rail, while the blue one will give us negative voltage. What we have here is also what we have here. Now the question is, what is producing the voltages? Well, we have 2 voltage regulators here. We have 2 voltage regulator ICs here. This one helps us convert the input voltage to the module to 3.3 volts, while this IC helps us convert the input voltage to 5 volts. And to get that input voltage, we will connect our battery to the module. This is the battery holder. So what we will do is to connect batteries here. We will connect AA 1.5 volts battery, about 6 of them. Each one is 1.5 volts. So when we have 6 of them, we will get 7.5 volts. When we supply that 7.5 volts to this our power supply module through this power jack, the regulators here will help us regulate that 7.5 volts to either 3.3 volts or 5 volts. And these are the batteries we are going to use. By the way, the Ettronics Hightech Arduino Kit does not come with batteries due to safety reasons. So I will connect these batteries to the battery holder. The first one, the second one, the third one, the fourth one, the fifth one, and the sixth one. These 6 batteries will give us 7.5 volts approximately. But with the help of these our voltage regulators, that 7.5 volts will be converted to either 3.3 volts or 5 volts. Now, we have connected our battery, we have connected our power supply module to the breadboard. If I turn on the switch, if I press this switch, this LED will come on, indicating that power is now present on our breadboard. You can see that the LED is on, indicating that the breadboard now has electricity. If I turn it off, it will go off, on, it will come on. So now we have power on our breadboard. Let's look at the other components we will use to build the project. This is the switch we will use to build our project. If you look at this switch, you can see that it has 3 legs or 3 pins. If you want to control one LED, if you want to switch only one LED on and off, you make use of the center leg or center pin and any other leg or pin. In this our project, we want to control only one LED. So we will make use of the center leg or pin and one other extreme legs of the switch. This is a 220 ohms resistor. It is included in the Ettronics Hightech Arduino Kit. You only need one for this project. This is a blue light emitting diode. The Ettronics Hightech Arduino Kit has both blue, red, yellow, and green. You can pick any color of your choice for this project. These are few male-to-male jumper wires. You have male-to-male jumper wires included in your kit. The ones I have here are shorter than yours. I chose these short ones because I don't want to clutter the area that I will be working on. Now that we have seen all the components we need to build our project, let's start building our project. We will connect the components the way we have them in the circuit diagram. The first thing I will do is to connect a jumper wire to the 5 volts rail of our breadboard and connect that jumper wire to any hole in the middle of the breadboard, as you can see here. Then the next thing I will do is to connect a switch to where I connected the second leg of that jumper wire, which is here. So I will connect the switch, one leg of the switch, to this hole where I connected the other leg of the jumper wire. So I will connect it like this. You can see it that one leg of the switch is connected to where this jumper wire is connected. And you can see that we can connect something else here. And once we connect anything here, whatever we connect here will be connected to the middle leg of the switch, which we are going to do in a moment. So I will push down this switch. Okay. Remember that one leg of this switch, which is the extreme leg on the left, is connected to this jumper wire. Now, I will connect my resistor to the middle leg of the switch, which is here. And then I'll connect the other leg of the resistor somewhere here. And I will connect the positive leg of my LED to the other leg of the resistor. Remember that the positive leg of the LED is a long leg. So if I should put the two legs together and check, the long leg is this one. So I will connect it to the other leg of the resistor, which is not connected to the middle leg of the switch. So I will connect it like this. And the second leg I will connect somewhere on the breadboard. Now I'll connect another jumper wire to the negative leg of the LED, and then the other leg of the jumper wire I will connect to the negative rail of our power supply on the breadboard. Remember that on the breadboard we have a gap here. This gap shows that there's no continuity between this line and this line, and between this line and this line. For us to have a continuity between this line and this line, we will use a jumper wire to loop from here to here. And also, we can use a jumper wire to loop from here to here. So far, our circuit is ready. Let's go through the circuit again. We connected our power module, and then we connected a jumper wire to the positive rail of our supply, and that jumper wire we connected to a point or a hole in the middle of the breadboard. And then we connected one extreme leg of the switch to that leg of the jumper wire, while we connected one leg of the resistor to the middle leg of the switch. Then we connected the other leg of the resistor to the positive leg of the LED. And then we connected the negative leg of the LED to a jumper wire, which we later connected to the negative rail of our power supply. What we have here is also what we have here. However, what determines the voltage that we will get here and here is the position we fixed our jumper switch. So if we fix the jumper switch here, it means that we are going to get 3.3 volts. But if we switch it to this point, we will get 5 volts. The same thing is what we have here. If we switch this jumper wire from this 5 volts to this 3.3 volts, we will get 3.3 volts here. But as it is now, here we are getting 5 volts, and here we are getting 3.3 volts. So our circuit is ready. The next thing to do now is to turn on our power supply, and if everything is okay with our circuit, we expect this LED to come on if this switch is on. But if it did not come on, we will turn this switch to turn it on. At this moment, I don't know if this switch is in the on position or off position. So when I turn on this switch, when I press this switch, if this switch is in the on position, this LED will come on. If it is not in the on position, I have to slide it to this end. And if everything is okay with the circuit, at that moment, this LED should come on. But if it didn't come on, then we'll have to do what we call troubleshooting to find out what is wrong with the circuit. One more thing you should know before we will test the circuit. Anytime you are building a circuit that requires you connect an LED in the circuit, make sure you connect a resistor to that LED in series. A resistor helps to reduce or limit the amount of current that flows into an LED. If you don't connect a resistor to an LED in a circuit, excess current may flow into that LED and damage it. So, to make sure that doesn't happen, we always connect a resistor in series with the LED. And because the work of this resistor is to limit the amount of current going to the LED, we call that resistor a current limiting resistor. So if you are using 10 LEDs in a circuit, you must use 10 resistors in series with those 10 LEDs. All right, let us now test our circuit to ascertain if our circuit is working as expected. I will turn on the switch and will observe. And then I will slide this switch and will also observe what happens. Okay, I've turned on the switch and you can see that our power supply is on, but our LED is not on. So what I will do now is I will slide this switch. I will assume that this switch is in the off condition or off state. So I will slide the switch to the left, and if everything is okay with the circuit, I expect the LED to come on. So let me do that. And you can see our LED is on. So our circuit is working as expected. To turn off the LED, I will slide this switch to the right. And you can see that the circuit is off. So our circuit is working exactly as expected. If you are following this tutorial up to this point and you are practicing alongside and your circuit is working as mine is working, congratulations, you have just designed your first electronics project with the Ettronics Hightech Arduino Kit. However, if your circuit is not working, don't worry. We will troubleshoot it and find out what went wrong. Troubleshooting is the process of finding and fixing problems in a circuit. Here are a few things you can check. Check the breadboard power supply. Make sure the power supply module is switched on. If it is turned off, power will not be supplied to the circuit. As you can see here now, it is on, but if it is off, there will be no power supply to the circuit. So make sure to check the breadboard power supply. Check the connections on the breadboard. So if in the process of our connection, I placed this jumper wire here instead of here, you can see that by removing it here and putting it here, the LED did not come on. But if I put it in the appropriate position, it comes on. So always make sure the legs of the jumper wires and components are inserted into the correct holes on the breadboard. Incorrect connections can prevent the circuit from working. Check the LED orientation. The LED is polarized, which means it has a positive leg and a negative leg. Make sure the LED is connected in the correct direction, as shown in the circuit diagram. Imagine we reverse the connection of this LED. Instead of having it this way, and then I reverse it this way. You can see that the LED did not come on because the LED has been connected in the wrong direction. So check whether you make that mistake and then correct it by connecting the LED in the right direction. When you do that, the LED will start working as expected. Try different jumper wires. Sometimes a jumper wire may be damaged internally, even though it looks fine. Replacing jumper wires can help you identify and fix the problem. So if your project is not working as expected and you've tried some things and it is still not working, you can try changing the jumper wires, replacing the jumper wires with other ones. If the problem is the jumper wires, then by replacing them, the circuit will start working. Check the batteries. Make sure all the batteries are correctly inserted into the battery holder. If the batteries are inserted incorrectly, power will not be supplied to the circuit. So instead of connecting the positive terminal of the battery here, if I make the mistake of connecting the positive here and the negative here, and if I do it for all these batteries or for most of the batteries, we will not have the required voltage in our circuit and our circuit will not work. So these are the few things you can check to troubleshoot and fix your circuit. You should be able to identify the problem and get your circuit working. Assignment. Now it's your turn to practice. Add a second LED to the circuit and use the same switch to control both LEDs. Your circuit should be designed so that when one LED is on, the other is off. And when the first LED is off, the other LED is on. Try to build the circuit on your own before looking for the solution. We will go through the solution in the next class. Alright, so far in this video, we learned to identify the components needed to build a simple LED circuit. Connect a breadboard power supply and battery holder. Connect an LED, resistor, switch, and jumper wires on a breadboard. Understand the importance of connecting components correctly. Troubleshoot a circuit when it does not work. Identify common problems such as incorrect LED orientation, loose connections, and improperly installed batteries. We also learned that troubleshooting is the process of finding and fixing problems in a circuit. In our next class, we will continue building exciting projects using the Ettronics Hightech Arduino Kit. If you've not gotten yours yet, you can reach out to us via chat or send us a DM or email us to get yours. Or you can use the link in the description of this video to order yours online. Thanks for watching and see you in the next video. I am Instructor Izu. Bye.